In our lesson today, we are looking at equivalent equations. For some time now, we discussed about linear equations and some transformation rules of equalities that help us solve linear equations. Now, when we talk about equivalent equations, obviously we are comparing equations. So, two equations are said to be equivalent if they have exactly the same solution sets. Okay, so when you talk about solution set, you are referring to set of values of the variables that makes an equation true. All right, so let's look at the example. Show that this equation, okay, and this equation are equivalent equations. So what we do is we look for the solution set of the first equation, look for the solution set of the second equation, then we compare them and see if they are the same. If they are, then they are equivalent equation. All right, so let's solve it. So let's take the first equation, which is 2, into bracket 9 minus x minus 3 plus 4x, okay, equal to 4x minus 5 in brackets, all right, minus 8. Okay, so this is what I have. So we do what? We remove the parentheses. So let's move. So I'm going to get minus 1x, okay, that will give me this, okay, minus 1 times negative 3 will give me positive 3, all right, plus 4x, okay, then I'm going to get 4x minus 5 times x will give me minus 5x, all right, minus 5 times positive 2 is going to give me negative 10, okay, minus 8, all right. So let's move on. So here, what I do here is I add 9 plus 3 to give me 12. The negative x plus 4, all right, 4x is going to give me plus 3x, okay. Then 4x minus 5x, okay, is giving me negative x. And obviously this is giving me negative 18. Okay, so what do? I still have some parentheses here, so let's take that one off. So 2 times 12 is going to give me 24 plus 2 times 3x gives me 6x, which is equal to negative x minus 18. All right, since we are looking for x, okay, let's eliminate this 24 and we apply here, we are applying the subtraction rule, okay, the subtraction property of equality. So I'm going to subtract 24 from 24, okay, plus 6x equals to negative x minus 18 minus 24, okay. So if you have been following us for some time now, you understand why when we subtract 24 from the left hand side, we do the same to the right hand side, okay. So 24 minus 24 is going to give me 0, so obviously I'm going to have 6x here equals, this is going to give me I think negative 42, right? So this is what, 42, okay. Then we move on. What do? Since I want x to stand alone here and the constant at my right hand side, then I have to eliminate this s over here. What do? Then I have to add x to this to cause this s to what? To be eliminated. So what I do is I use my addition property of equality, okay. So what I'm doing to the right hand side, I do the same to the left hand side. So I'm adding plus x, okay, to both sides of the equation. All right, so I'm going to get this plus x, all right, minus 42, okay. 6x plus x is going to give me 7x, all right, equals to negative x plus x is giving me what? 0. So I'm going to get negative 42. All right, so what do? I divide both sides by 7, all right. So this is going to give me x, okay. All right, so 7 goes here 6 times. So my solution set will be s is equal to negative 6. That's my solution set for this equation, all right. So let's do that for the next equation, which is s minus 2 equals negative 3. All right, so I have to also find the solution set for the second one, since we want to find out whether they are equivalent equation. So what I do is I multiply both sides by 2, all right? So that's the multiplicative rule of equality. So what I do here, I do the same 2 here, right? So this is going to cross these 2 out so that x can stand alone. So x is equal to negative 3 times 2 is giving me negative 6. All right. So here I have my solution set as s equals negative 6. And here also my solution set is giving me negative 6. If you compare these two sets, solution sets, you realize that they are exactly the same. Hence, these two equations are equivalent equation.